going to show you something special I was working on. This will probably be something that a lot of you guys that like ZFS are interested in. I've been working on this for months. Well, a few months, I guess you could say. So what this is this is a kernel builder. Right now, it's only going to be for Dev1 and Debian. You could probably get away with using it with other distributions if you wanted to, no problem. But the reason I chose those as my base to start, I'll eventually have it I'll probably package it I'll probably end up packaging it better with like PKG config and stuff and make it more cross-platform, cross-distribution compatible. But right now, it's guaranteed working for Dev1 and Debian. So what this is this is a kernel builder, and it's a kernel builder that's based on the Xmod Linux kernel. One of the reasons I chose this kernel is just because this already has some internal performance enhancements done to it, and it's to build in the ZFS module. So what makes this kernel, in my opinion, better than other kernels is it, in fact, if depending on the kernel build you choose during the configuration and building of the kernel, it's going to build in all the modules, and believe it or not, it shuts off all module loading. Now, I'd say just about probably everyone running Linux that isn't running a custom kernel or kernel they built themselves, they're going to have module loading enabled. Now, one of the benefits of having module loading disabled and your modules built in, it provides, I believe, for better memory protections, and you get less page faults, and that's because it takes those, they're considered more of kernel space now than they are user space, and that has some advantages. Couldn't tell you all what they are because, well, I didn't dive that deep into it myself, but I can tell you it's better, and it's a lot more stable. It's just more stable whenever you're using built-in modules that are already built in the kernel and you're not having to unload and load modules, and it also provides for some security benefits. Another thing about this is it supports EFI stub booting, so the initram FS is built into the stub now. Now, with most distributions, it's actually not like that. What you're doing is you're loading in the initram, and then you load the kernel. Well, the initram FS is built into the kernel. Also, the initram FS is custom. It's one that I built. It actually, in my opinion, is a lot better than any of the other initram FSs out there, because it's one, it also has a static binary nano in there, so you can use nano. So the idea behind the initram FS I put in there is eventually it's going to be almost like a micro Linux, so you can load into it and do your pool recoveries, and it will have like an instant command set, so you can drop into a pool recovery environment to make it easier to recover pools if you do need to recover any of your pools. One thing that has not been done with this build is that this also installs the ZFS developer version, and no, usually most of the time it's not good to use the development version of a package-based Linux software, but according to OpenZFS own comments on their GitHub page, they actually say, from what they make it sound like, is it's actually smarter to use their development version than it would be to use their release version in a lot of instances. So that's what I'm doing. So another thing I plan to do with this is I plan to make all the libraries built in, and I might even be doing some research on how I can even make some of those libraries Rust based. I'm not sure about how the possibilities go with that, but I'm going to look into that later. But the main thing is to make the libraries static. And the reason for that is because static binaries, they usually contain like all the what is it, compiler symbols, the kernel symbols, stuff like that. And they usually all packaged together in like one binary. So like, for instance, if you're using the Rust-based version of Fuzzy Finder, you'll know that the libraries and the binary are built into one binary instead of like the regular Fuzzy Finder, which would just be the regular Fuzzy Finder, where the binary is separate from the libraries. So you gain a more stable environment. One of the I guess cons of it would be that those you're taking a little more space because a lot of times you're going to be including the symbols and stuff, especially for different architectures that aren't normally needed. So that's one of the cons, but the better part of it is the stability increases by a fair amount. And the reason I'm going to do that, do the static libraries eventually, is because it's ZFS, it's our file systems. This is like, from what I know, like the, most used file system throughout the world, especially, well, I wouldn't say most used, but in the professional environment, the most used, like in data centers and stuff like that, obviously for its reliability. It's proven reliable for me more than once with its recovery capabilities. I've done like Z rollbacks, and I've had one where whenever I was building this, I was actually switching around different kernels and mismatching symbols and switching around encryption types while I was testing some performance stuff for the pools, and I ran into an issue where whenever I switched from, what was it, Blake to Edron or whatever, the checksum, my pool messed up, and it pretty much, anyway, I did a rollback on it, and it actually surprised me. I was able to roll back to the last snapshot I did before I made those changes, or that compiling, whatever. So this is just something I've been working on. So this is something I think that a lot of you would be thankful for. You're going to definitely get a little more performance out of this, and you're definitely going to get a little more stability out of it. Also, what I've done is I've packaged in Hard Disk Sentinel. They've given me permission to use this, the Linux version, however I see fit. So we're going to be doing that. Hard Disk Sentinel, it's really nice. It's actually, it's sad more people don't use it, because you go on YouTube and stuff about how to check hard drive health and stuff like that, and you usually like see SmartMon tool and then a few other things out there. But I personally think even the command line version of this is probably the best. I like it because it factors in a lot of things, and it gives you a percentage based on it. So eventually what I'm gonna have is there's gonna be a, whenever you do like your list your ZFS volumes, it's also gonna have some command line stuff from Hard Disk Sentinel that gives you a percentage of your physical drive health, and I will show you that right now. So you can do HD Sentinel. Oh wait, that's right, I just compiled for a different library. Let me see if I can do it on my server real quick to show y'all what's good about this. HD Sentinel. Okay, here. Okay, so this is Hard Disk Sentinel. This is going to be included in the ZFS Ultimate Kernel Builder, and it is going to be it's going to be giving you a breakdown on your hard drive health. So as you can see here, it does it really nice. So it's not going to be giving you a whole bunch of hard drive smart status that hasn't been broken down yet in a layman's terms. So it's going to be a lot easier to understand than like SmartMon tools, which is why I like it. But it's very accurate too. So it's not something where you're taking too much off of the techie geeky stuff and dropping into something that's less reliable. It's extremely reliable. I've used this thing on like literally like thousands of hard drives, and it never fails me to be accurate in what it's saying. So if you look right here, like it's going to say the device number right here. It's going to give you the revision, HD size, the temperature, and the health right here. So this is the SCSI debug device. So because it's the debug device, it's saying 7 megabytes. We obviously know that that's not a regular hard drive, that's just the debug drive. Well, you go up here, there you go, regular drive, shows the temperature, the highest reach temperature, and the health. Another thing nice about this is not anything that's going to be running in your background. So eventually what I'm going to be doing is these are going to be set as variables, and they're going to work with something like ZF, zpool list dash EP. So they're going to be working like this, and I'm going to end up creating a custom command that has all this reformatted and done in a nicely table, and it's going to have variables set from over here. Now, this should help y'all a lot whenever it comes to determining the health of the actual drive instead of just seeing something like online, because ZFS specialty is not really to determine your drive health. They'll tell you whenever you're having I/O errors, maybe through like your dmessage kernel log or through your zpool status command. So what this is going to do is this is going to increase the capability of your zpool list command, and it's going to go ahead and have insert information from variables from HD Sentinel, put it here, and it'll be colorized and probably be running through bat. So it's gonna look something nice, like maybe like something like this. It's gonna be tableized, and maybe we'll have some syntax highlighting done to it. Let's see, yeah, like something like that. So it's got some syntax highlighting. That's the C-based syntax highlighting, but yeah. So it'll be something like that. So it should help you all out a lot when it comes to identifying problems with your pools and getting a information overview of everything that's going on. Also, something I'm going to be adding here is your arc cache hit ratios. So pretty much the goal would be to have like one zpool command where you're checking, like you're getting all your information in one command, so you're not having to run like 3 or 4 different commands, and it'll be have some syntax highlighting and some other stuff done to it. So that's some of the stuff this is going to include. Let's go ahead and I'm going to start an installation. So I'm about to bring this out of like the really early alpha stages and test the stages into beta stages, so people can start installing this safely on their systems, going over the source code and seeing how they like it, you know, and what it's going to do for them. So now go ahead and run the install script, and this is going to give you, except I'm not going to be doing it with ZFS because that's going to make everything nasty looking. Okay, so the first thing it's going to do is it's going to ask you if you want to install the dependencies. Now, a lot of times developers like to put the dependencies on the GitHub page because right now this is only for 2 different distributions. It's going to ask you if you want your dependencies installed. So like if you say yes here, what it's going to go ahead and do is it's going to go ahead and run the install for each of these one at a time. So make sure you're going to want make sure all these packages are, there's some extra ones in here you probably actually don't need for what you're going to be doing, but they're on here just in case you want to mess around with some development stuff. So these are going to be your dependencies you need. So I'm not going to need those right now because I already have them installed. So I'm going to push end for no. And then the first thing you're going to see here is going to say Ultimate ZFS XMod Kernel Builder by fixitpc.net. For all don't know, this is my website. Obviously, I'll do that. Know that probably because of, you know, I don't know, my business name and stuff. Now, if you go down here, what it's going to tell you is it's going to list some of the specifications of your system. Some of this stuff isn't done yet, but I'm working on that. So it's going to say, hey, your current kernel version is 6.0.9 xmod 1. So that's my current kernel. This would be also the kernel that's going to be installing. Another thing I'm going to add in here is I'm going to add the ability, if you want to install the true real-time xmod kernel. That'll be in here too. I don't even know if that's how you pronounce that. Maybe it's not Zanmod, Xmod, Xeonmod, Zemon. I'm going to say Xmod. Another thing is installed ZFS version. It's going to show your installed ZFS version. For all that don't know, the 9.9 right here, developer version. Then it's going to go ahead and list your host CPU type. For me, it's going to be 2 of these pretty little Xeon E5 2696s. Those, by the way, are like my favorite CPU for now. They do a pretty high turbo, and they're like 18 cores, and they're like to you CPU guys, this is like the hidden, almost free CPU. You look up the price of these things, and they're like under $100, and they're the same thing as a 2699 V3. It's just these 6s right here were made for OEM specialty, so they were never listed by Intel. But they are the exact same thing as a 2699. In fact, a little better because their turbo's like solid high. So anyway, besides that, that's off the point. Instead of spending, you know, $500 for a CPU, you could spend like under 100. And anyway, so now here are the Numanode CPUs right here. So I have 2 processors, right, and This is the node setting I had, so it's breaking down those two processors as four sockets, which I only have 2 sockets, but that's just the new node setting I have set that's in the BIOS. It's also going to do your no hertz CPUs full. So eventually what's going to be on here is it's going to, like, if you have a Windows kernel-based virtual machine, you're going to be able to tell it that, or it's going to go into your XML file and check if you have a KVM, and it's going to go ahead and give you the recommended no hertz full and the RCU no CBUs. It's going to give you the recommended options for that, and maybe even do an auto calculation based upon your CPU cores. And then it's going to offset the RCU no CBs with a real-time priority of 99. I know that's actually insane, but that's like fully real-time in your kernel on your K threads, so it has like a lightning fast response. And I'm going to do some other things so you'll be able to maintain stability, because doing a real-time kernel with this 99 and then break it, yeah, sometimes it gets kind of confusing. There's a lot of stuff you got to get into with the RC threads and stuff. Anyway, I'm going to try to automate that for y'all. Then you're going to have the total memory. So it's going to list your total memory. And then it's going to say, hey, huge pages, 1 gigabyte. And then it's going to, believe it or not, the allocated, where it sees allocated huge pages, it's going to automatically calculate a arc min and max for you. So by default, at least from my knowledge as of today's date, arc is going to go up to a 50% memory ratio. So what I have this do is instead it increases your arc max to 75% of your RAM, and it puts your arc min at 50%. Now, and it's going to enforce it at that 50%. So depending on that may or may not be dangerous. So there's a few things I got to add. So the reason for this is because this would be enforcing a 50% minimum usage on your arc, and this would be a 75 max. And what this is going to do is this is going to help the caching better, because it's going to cache more into your ZFS arc. And it's not going to be based on their auto 50% algorithm. It's going to be an enforced 50% min and an auto calculated 75% max. Now, the reason why I say is because the max is going to be usually auto lowered, so it's going to stay in between 50 and 75 depending on other memory usages going on in your system. Now, the reason this is good, it would even be better, in my opinion, to run less RAM, like on your KVM, but use more of your ARC RAM. The reason for that is because a lot of time you're going to be using the ARC RAM for files and stuff you're going to be pulling up, or some of that data set metadata and stuff for your KVM anyway, right? So why not just give your KVM a little less and your ARC a little more, right? My opinion. It's going to show you the current root pool, which for me is going to be our pool, and it's going to show you your current pass-through ID. So when it builds the kernel, because this is all built in, you guys that like to do KVMs, sad to say you can't use the VIFO method of pass-through anymore, which is a perfectly fine sacrifice, I believe, to have an all built-in kernel. Instead, what you're going to be using is the PCI stub IDs. So when you build the kernel, this thing's automatically going to go ahead and look for those stub ID sets, and it's going to set them in the kernel. Now, these have to be built into the kernel with the PCI stub. So even though these are built into the kernel, VFIO, just like if you're using like and because of that, like let's say you're using the built-in NVIDIA drivers that come with Linux, and they're built into the kernel, right? So what will happen is that NVIDIA driver will grab this before VFIO, and VFIO cannot unseize that from the kernel because it's built in. So it's just going to crap out in itself, or your whole system's going to lock up immediately when you try to boot your KVM. So PCI stub IDs, one of the abilities it has that gives it an advantage over VFIO is that it can seize your video card from the built-in kernel module. VFIO can't do that. So there might be some pros and cons to that, but having all built-in kernel, I'm definitely pretty sure outweighs that. So that's why I chose to do this with PCI stub IDs. Then it's going to look for your ultimate ZFS scripts. So the ultimate ZFS scripts is like the thing I was showing before with the HD Sentinel, how you're going to have like better use case scenario commands. That's going to ask if you want that installed. So I'm going to be as least intrusive as I can to y'all's system. So when y'all install this, you're not just getting a whole bunch of crap installed. You don't know what it is or where it is. So I'm going to have it ask you some questions first. And as long as you agree to those questions, then those changes will be made to your system. You can also take a look at the source code to see what y'all do and don't, and what y'all agree with and what y'all don't agree with, and give me some verbal feedback. I consider myself a script kiddie, but I definitely have a good amount of knowledge on hardware and how the kernel works and the drivers and etc. and how to get the most performance out of stuff. So I'm taking some of my script kiddie skills and putting them to use here for y'all. So make something maybe y'all like. Now, if you go down here, what you're gonna do is you're gonna see a warning. Make sure drives are imported by blah 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 dev. It's a tune ZFS code does not like the cache file. So another thing, a lot of times you have zombie pools. I'm sure that you guys that are experienced with that ZFS cache file know about the zombie pools and some other stuff that happens with it. So what I've done is I've completely disabled the ZFS cache file. You're not going to be using it, right? None. No using the cache file. So we're just disabling it. It's getting axed. We're taking an axe to it. Now, you're probably still going to need it like under certain recovery operations, maybe. So maybe I'll put an option in there to like under ZDB or whatever recovery options, because it can help with the. But in other ways, don't worry about it. So I axed it out. Now it's going to ask you, do you want to tune your pools? So I have a specific specific pool tune that I recommend to use with this. I'm going to go ahead and push enter real quick. So it's going to say, hey, here's your pools. I got a Dev1 pool, a Redux pool, an R pool, and a ZFS Ulti-Test pool. I'm going to do my R pool. So I'll type in R pool here. Go pull it all X tune. Push enter. This isn't color, as I still got to work on it. Anyway, so it's going to go ahead and give you a breakdown as it's doing here. I actually loaded that. I think that's being loaded bad. Anyway, so I'm about to, this isn't I got a newer version I'm about to upload now that I'm doing this video. So if you look right here, it's going to give you your block size choices. So it's going to say, hey, pick a block size for your pool tune. And so right here, I kind of give a basic common sense based breakdown on how those block sizes are going to affect you and what I recommend. So your 1K blocks, that would be ultra high IO NVMe drives. So the newer, quicker, and the more ridiculous amount of money you have spent on your NVMe in the current, and I don't know, the last year or so, if you spend a ridiculous amount of money, you're going to have a really nice NVMe, right? So it's going to be able to push insane IOPS, and you're going to be able to push insane IO without stressing the drive too much. So that's why I have this. So if you now it's going to say it's either recommended for this. So if you have like a really insane fast, ultra high IO NVMe drive, and you don't mind sacrificing some of your big file size read and writes, then this is great for this or CLI based work only. So the lower block sizes have the better performance to get stuff like sed and awk, because they're able to parse those little files and get in those text files quicker because of your drive block size, right? I personally recommend 16K even if you got a fast NVMe drive. A few reasons. Once you get too low on these block sizes, you will get a, how should I say this? You can have IO locks, where your drive is stressing itself too much during certain operations, then you have other operations waiting because of the amount of IO stress you have. Especially if you're doing like a lot, like you're compiling this, doing this, parsing through these files, and you got like a few heavy-based operations going on, then this might actually be more negative than positive, especially when you're working on smaller files. So I say 16K, 16 or 8K, 8K for you guys with those newer, better NVMe's. The reason for that is you're not going to be stressing your IO. It also stresses your CPU more too whenever you're doing those small block sizes. But the great thing about small block sizes, you're going to have really fast response when you're doing command line work on multiple small files. It just gives you a better, more latency feel. The computer's like responding faster when you're working with certain things, right? The con of the smaller block sizes is you lose read and write speed when you're working with larger files. So, but if you have a newer NVMe and you're using like 8 or 16K, you'll still be able to hit those really, high insane numbers that you probably wouldn't mind sacrificing some for anyway. Like, still be doing your full 1 gigabyte a second for your 10 gig network and blah, blah, blah. So that's why I go ahead and say, hey, pick 8 or 16. That's what I recommend. So I'm going to go ahead and do 16, right? I'm going to do 16K. And then the next thing it's going to go ahead and do is going to pop up, hey, these are your options for your pool tuning. So what it's going to do is option 1, it's going to set your, that's the block size you just set. Now, for option 1, this is going to be with dedupe enabled. This is actually newer, so it's actually going to tell you, hey, this is for dedupe this. So anyway, option 1 is if you want dedupe on. Dedupe is very, very CPU and memory and drive heavy. Well, not too heavy, but maybe heavy. And that's also, I don't know. Anyway, dedupe's great, but it can not be so great at the same time. So, yeah. This kernel is mainly based for speed, so I don't have that as the recommended option. I have option 2 for the recommended option. So right here, dedupe is off, right? But your LZ4 compression is still on. So under a lot of workloads, even with LZ4, you'll actually be benefiting from having your LZ4 compression on, but you might barely hit, you might increase latency just a slight hair. But in other workloads, you're also going to be getting a lot of benefit from that LZ4 compression being on. So one thing LZ4 is going to do too is LZ4 is going to add a slight amount of stress to your CPU. Now, if you have somewhat of a modern CPU, you probably shouldn't even be taking that into account, right? Because, well, the CPUs now are just so dang fast, it's not going to stress that much anyway. So I don't even worry about that too much. So this would be my recommended option. If you guys are trying to get the lowest possible latency, you're going to want that dedupe off and you're going to want that compression off. Or maybe you just got, an unfathomable amount of hard drive sizes, laying around. Maybe God's your best friend and you have like, I don't know, 100 terabyte drives from the future laying around your office. So you're obviously not going to need compression anymore of that. So if that's the case, and God's your best friend, then we're not going to have to worry about that. So you probably go with option 3. Anyway, so that's just stuff like that you'd want to know based on when you pick these options. So I'm just going to go ahead and say, hey, let's go ahead and do with option 2 here. And it's going to say, hey, tooling your pool, please be patient. Just reminding you, don't be an asshole because we can't do it fast enough. So just reminding you to be somewhat of a good person. Just don't be an asshole, all right? Don't yell at your computer or throw it across the room. For me, it said cannot mount our pool. That's because before I've ran a, anyway, just completely disregard that. That's crap. Just don't worry about this message. And then it's going to say, do you want to tune another pool? So if you do yes, it's going to walk you through that procedure again. Like whenever you do the upgraded one, it's actually going to ask you for the pool you want to tune again. Then it'll drop back into this prompt. So like I said, this one's like a version old. So anyway, just do that again. And I'm just saying, no, we're done with pool tuning. The next thing it's going to be like, hey, so I'm trying to be respectful, y'all. It's going to say, hey, do you want to install the cron jobs? Because, I don't know. So it's going to say, do you want to install the cron jobs? So we can say yes. I'm just going to say yes. If you want to view the cron jobs first, you just push V for view. And I'm just going to say yes, install them, right? And I'd say, would you like to install the custom HTOP layout with Arc? This will override your current HTOP theme. So the current user you're running this as, well, actually you got to run this thing as root anyway, right? So what it's going to do is it's going to make your HTOP look something like this, which I think is a lot, it's gorgeous compared to the regular HTOP, right? It's because it's giving you a lot more data and it's organized in a way you can actually see what the hell's going on. So this is my current system. As you can see, it is well, I don't know. I guess it's committing suicide based upon everything I'm doing currently at the moment. So if you look right here, it's going to give you a breakdown of your memory. It's saying, hey, I'm using 65 gigs of my 128 gigs of RAM, and all 36 of my single-threaded cores are being stressed. It's actually not really like 100%, like some of this is wait time. And then anyway, so go down here, it shows your net, shows this, shows your ZRAM. I actually think I'm going to remove this because I did a lot of testing. I tried to incorporate ZRAM and your swap into this. So based upon all my performance testing, I found out that get the very most performance out is, believe it or not, I don't know if some of you guys are going to like this, but swap is removed out of the kernel because I just don't expect people to be using anything under 16 gigs of RAM anymore. And I've changed some of the settings for your virtual memory, for how the kernel handles virtual memory. So because you're not going to be using that swap, it's not going to expect that swap to be there. So it's going to just drop the cache on your RAM, right? Which, just based on my testing, you're going to get a lot more performance benefit out of that. Instead of swapping that with the drive, it's just going to, hey, we're just going to drop that cache and pull in the new stuff you need. So that's how it's set. And then it's going to show you your huge pages down here. So right now I have my Windows 11 virtual machine running on 32 gigs. And as you can see, my ARC is at 54 gigs. Something I noticed here, I don't know if it's because of an update or what, but as you can see, it says ARC, and I have 26 uncompressed, 3.4 compressed. Anyway, it shows your ARC here, compressed and uncompressed. Yeah, for some reason I think they might have this switched around because your uncompressed. Oh, no. Yeah, that's right. So it's showing 3.4. So it's showing 3.41 compressed. So your ARC is compressed, right? And then it's being uncompressed. So that 26 gigs of ARC is actually being translated into only 3.41 gigabytes of memory usage. And then the ratio is a 7.67 to 1, which I don't know about you guys, but when it comes to compression ratio, the ARC compression is amazing. Yeah, so that's why I say let's use as much of it as we can, because it really is really good. Yeah, and it just shows you some basic IO stuff here. Anyway, I think this is a nice HTOP layout. It also does it in tree by default. So, I don't know. I'm pretty sure most of y'all would want that. So it's gonna do that for you. If you say yes here, it'll do that for you. And then it's going to say, what configuration do you want to use? So I'm going to add a spot here so it actually shows your previous configuration. So whenever you're building this kernel, you can build it for either the current host system or you can build it for another system, right? So if you're building it for another system, you know, you could save it as a name, blah, blah. Anyway, my point is your configurations for now are based on your host name. So you'll be able to load up your configurations based on host name or save them for a new host. So I'm going to say, let's pick from a list, right? And so what it's going to do is it has a list of variables written to a file, right? And I can go ahead and pick. So these are some of the machines that I've been doing my ZFS Ultimate Kernel testing and installations on. So let's say I want to go ahead and load up my main rig in all lowercase, which would be my main rig, which would be the one I'm on now. I just type in main rig, right? And now it's saying, hey, picked host name is main rig. Would you like to save this configuration under a new host name? So it's saying, hey, if you want to use this for a different system, now's your time. Or you can just make up whatever name you want. So whenever it gets done at the end of the installation process, when it installs the kernel to your boot drive, if you have any name in here other than what your current computer's host name is, it's going to save it into a different folder under that boot drive, so that when you're rebuilding grub, it doesn't pick up that kernel and try to boot to it. So in other words, it's not going to completely interrupt your boot process. It's just going to put it in the other folder. Now, if you're using your same name as your host, then it's going to drop it right into that boot folder, so that when you update grub, it will be picked up for booting into. So I'm going to say no. Now what it's going to go ahead and do is something I think a lot of you guys are going to like. It's going to give you a breakdown of your current kernel parameters. Now, the current parameters that are in here are going to be the kernel parameters I have set. I think I'm going to add an option to import your current ones, but for now, it's going to use these. So I'm going to put yes, I want to edit. And if you want to edit, it will just open up Nano. I chose Nano because a lot of guys don't know Vim, and Nano is just easily comments instrument. Hey, I got my left and right arrow keys, I got my enter, and I got my keyboard. Let me enter this stuff and push Control S for save. Right? So this is based on you pressing Control S. So you're going to want to make sure that you're going to go through here, right? So it's automatically going to insert the information on your first run for your PCI IDs. And it's going to auto-calculate your huge pages and what they should be, or what it recommends. And the same thing with this. So on your first run, it's actually going to have entries here for your ZFS arc min and max, and it's going to have an entry here for your huge pages. I've also learned recently that either based on some kernels or some distributions, I've noticed when I ran this on the other distribution, it did not do some of the, I don't know, algorithmic math correctly on that installation. So the numbers were weird here. So you just couldn't use it. It wouldn't hurt if you keep it enabled, but it wouldn't know, because this is going to be done on like byte size memory input. And I'm also going to add it later, so you can just, you know, if you type in anything GB, it will recognize GB and automatically convert that to a bytes. That way you don't have to worry about, you know, doing a Google or pulling up your converter. You just type it in there. And then as you see, my IRQ affinity is set. For y'all don't know, this right here is where your interrupts are going to, right? So whenever you're doing a real-time kernel, from my understanding and based on my experience, you do not want your interrupts, and you don't want your RCU, you don't want your callback threads. You don't want your callback thread smacking up against your interrupt. So you can set your interrupt cores. So these are going to be the cores that your interrupts are being processed on. Also, you're going to want to make sure that a lot of times it's good to keep those away from your KVM, because your KVM is going to reroute them anyway, right? Like QEMU, your libvirt, KVM, it's going to reroute those interrupts properly. Well, QEMU, I should say, and your KVM, and part of that is the kernel modules. So anyway, it's going to do a lot of that for you anyway, right? So, probably don't know, a lot of times you can get, you get better interrupt processing by forwarding some of these interrupts directly to the correct cores on the virtual machine, but that will also increase your CPU latency. So what I just do is I say, you know what, we'll let the KVM figure out all that routing by default, and we're just going to do that, right? And then it depends if you have, like, your IO-MMU mapping, a few other things. Anyway, so yeah, that's that. That's how it's going to set that. And all this right here is default. So this is all default for Intel-based systems. I'm going to add default for AMD-based systems. Maybe I can find an AMD guy out there that wouldn't mind helping me, because I don't have a newer AMD system and I can't test some of the parameters that I would need to test. So maybe one of you guys got a spare rig laying around, want to help me. That would be nice. I'd really appreciate it a lot. So this is some default kernel parameters, and I've defaulted these for Intel, so you're always going to have these on. I'd recommend keeping them on. I just recommend keeping them on. One of them is that it increases your your NVMe IO queue depth. It doubles it from, and this is as high as you can go, is 2048. That should help with a little bit of drive speed. Then you have MVB, no ACPI equals yes. I'm not gonna worry about that. Your BFIO underscore PCI dot disable, yes. So, and then your PCIe ASPM, which is your power management policy, that's going to be set to performance. Then it's going to be PCIe ACS override equals downstream multifunction. Now, the X-mounted kernel automatically does have that ACS override patch built in, so you can go ahead and automatically call this. Then you have your BFIO IOMMU type, which is right here. And you have some of your virtual memory settings here. And your RCU use soft IRQ 0, or put a 1 there. I put a 0 there because that's how the real-time kernel is. So yeah, and whenever you anyway, yeah. So this is the current default settings. As you can see, it didn't do the FIFO priority of 99 for your RCU and K threads. So I'm gonna do some further testing and see if I can implement this too, like I said, based on auto calculations. So you'll have like an insanely fast real-time kernel if you choose to go the real-time kernel route. And your RCO, a lot of you guys, if you want to, I've seen a lot of guys do posts on, hey, how can I set my ZFS threads? Here you go. You set your RCU threads, like RCU no CBs. So this is telling the RCU threads where not to spawn the callbacks. Now, I think you still get 1 or 2 here and there, but anyway, I'm not sure about that. But this is going to tell your RCU threads primarily where not to spawn. And so if it's not in this list, that's where your ZFS core processing gets done too. It gets done on the K threads and the callback threads and all that. So the processing's being done on those threads, which is anything that's not on this list. So for any of you guys that want to know how to control what cores ZFS was taking priority on, there you go. That's that right there. And the reason this is going to be auto-calculated and set up like this, because I know a lot of you guys are into gaming and into stuff like that, and KVM, you like to run your Windows machine. This is going to take care of all that for you, so it's already giving you pretty much like one of the best setups you can have out there. And I'll do a video comparing my latency on my KVM later on, so you can see. It's really good. It's better than like 99% of people I could find on like the level 1 forums. In other words, like whenever I compared to like their benchmark stuff, it was really good. The latency was anyway. I spent like 6 months figuring out how to tune that thing and staring at the blue kernel options menu to get the really good kernel. Anyway, so yeah, there we go with that. Save that, exit that. And this is, hey, do you want to install the latest firmware? So after it gets done with asking you with setting your kernel parameters, and it's already going to have a list in there of the default ones that I recommend. You can put yours in there too. It's going to ask, hey, do you want the latest firmware? So what this is going to go ahead and do is it's automatically going to go to GitHub, and it's going to go to the official kernel.org GitHub page, and it's going to download the latest firmware and install it on your drive. So obviously I would hit yes here. Make -J36 command I found. I think that's something I gotta fix real quick. Interesting. Okay, so as you see, it just pulled in the latest XMod kernel. So what it's doing here is it's going to get, and it's making sure you have the latest version of XMod. Right? So it's pulling in the latest XMod kernel right here. And it's going to go update, so we'll just wait for this. Okay, so I made some changes since last time. Let's go ahead and go through it real quick. Just ask you for install dependencies. No. See, the screen looks a little different. It says Ultimate CFS XMod Kernel Builder by fixpc.net. Press enter to start the installation. Go ahead and press enter. Then I'm going to type in the save name, which you don't. I'm always recommend using like dead on your host name. There's like just random mumbo jumbo here. It's because I was doing some testing. Just don't worry about that. And then it's going to ask you, do you want to save it under another name or this name? Now, you're going to want to make sure that that the save you're using matches your host name. Now, you can save it under other names for testing, But if you want to get the compiler benefits, you don't have to, but if you want to get the compiler benefits, you're going to want to make sure it matches your host name. So after you like change the name, you set it back. I'll probably add some options later to automatically do that. That way, like, you can use this for more of the, like, these are other systems I'm using, but you know, you can save it like whatever name you want and then like change it back later. Uh, no, I'm gonna do that. No, I don't want to edit my parameters. They're good. Okay, I'm gonna go ahead and do the pool tune now. So press enter. Give you all examples. So this will tune your pools for you. I'd recommend, you know, 16K block size. I'm pretty sure we already went over this. That, and then it's gonna go ahead and show you, you know, tell you about some of the benefits and stuff like that. And then I'm gonna go ahead and say 16K. And then it's gonna go ahead and give you a quick little echo here. Now, this is something I'm gonna have to change, but I'm not gonna worry about it for now. As you can see, it's putting this into its in localhost, blah blah blah. That's because I was having that as the prompt for the install, so I'll probably have to figure out how to change that later on. Actually, what I'll probably end up doing is I'll probably do an async prompt and have it over here or something like that later on. Okay, so I'm gonna go ahead and press option 2. That's the one I recommend for, you know, most users default. And it says tuning your pool. It's gonna tune the pool you selected. You give it a second. Okay. Invalid property. It looks odd to make change there anyway. Okay, so I'm gonna push N for I'm done with the pool tuning. And then would you like to install the latest firmware from kernel.org? This doesn't work right now, but I'm gonna have it so you can go ahead and view like the change logs. In fact, whenever you just start this, it's gonna go ahead and give you a preview of each change log for the kernel and the firmware and blah blah blah. And but no, not now. Skipping firmware update. Okay, and that's it. Now it's asking, do you want to use the standard kernel or the real-time kernel? And it's going to show you the latest real-time kernel and the latest standard kernel. So I'm going to go with the real-time. So I do a lot of audio stuff on here. And then because the last kernel I built was not real-time, so it's going to go ahead and do is it's going to go ahead and wipe all that stuff out. And then it's going to reuse every time you do go into the make menu config and you recompile the kernel. It's actually going to like reapply your old settings, so you can always like go back and change one or two things, and it will always be saved. So it's really nice for like testing out different kernels and doing performance checks and stuff. And later on, I'll probably have an echo right here too, so every time it will always show you like an echo. Like I'll probably have login. There's a few other things I want to add. I want to make it like a really nice kernel installer, like a custom kernel builder. This is like a work in progress, but it's just now to the point where I'm gonna release it as beta, so y'all can download and install. Like I said, first create Debian Dev 1. Okay, so applying kernel configuration from the last one. ZFS kernel present will update instead. So this uses the developer version of OpenZFS, just because pretty much based upon what I've been reading on like the readmes and stuff, they actually kind of recommend using the developer one. Like if you have any problems with the regular one, usually you want to stay away from rolling, but I guess since they're just so good at development, I guess it's good to use the development one. So I'm using the development one. That's just what I've been using. I recommend it. And then as you can see, it brings up a nice black style make menu configuration. And you can just go in here and, tune stuff. So I'm also gonna, right now, this is like a fully loaded built-in kernel. As you see, there's no module loading, like none. There's none. It's got like pretty much like all your file system is enabled, your overlay FS for Docker and stuff like that. You go over to here. It's got some of the things I have changed is I have taken a few of the security things off, just for performance reasons, and like the kernel hardening stuff. One other thing too I've done is if you go under to right here, so it's got memory hot plugin and stuff like that. One thing I want to change on mine. Yeah, and this is something else that has enabled that's not enabled by default, contiguous memory allocator. So this is good for like direct memory access. It's not enabled by default in the kernel, and you actually have to set a size. So this is set to use 5% of your RAM to use it to help with the DMA subsystem of the kernel. It'll help stuff like your video performance and stuff like that a little better. Yeah. What else here can I show you? Another thing too is under power management, it's got the default governor set to performance. What else do we have here? Oh yeah, these are the built-in kernel parameters. So like all the parameter lists you edit, they get put in here. So they're built in. All that stuff gets built in. Since it's the real-time kernel, I'm going to change mine to real-time. Another thing is too, there's actually quite a bit of stuff you can ask for more performance. Actually, but because I'm doing development, I keep Docker on. But if y'all want to get more performance, see all this stuff right here, axe it. Like turn this all off. Docker's not going to work anymore unless there's a specific way you can install it or change some stuff. But it's going to freak out and it's not going to work if you turn this off. But this does get you a little bit boost in performance. So what you'd be doing here is you'd be pretty much axing all the kernel's ability to manage your resources, and everything's just going to run wide open, which is usually going to benefit most people unless you're doing like heavy server workloads and you're always bumping up at like around 100% usage. Then you're going to need this. But if you just want the really fast latency, response, gaming, KVM, stuff like this, it would actually help to actually turn a lot of this off, to turn it all off. The only one you'd keep on is the CPU controller one, and you'd want to keep group scheduling, and you'd also want to turn, you could keep the one for FIFO off, like your KVM would be doing the FIFO real-time threads, so it wouldn't mess with those anyway. What else here? Yeah, it's pretty much it. You can access a lot of this off too. Like you can turn like your express port bus support off, and it'll work. Like you can just turn like a lot of this off for like managing your PCI resources. Like whenever you're accessing like kernel resources, but you'd want to keep this stub driver on so you can still do the KVM pass through. Yeah, so pretty much if you want more performance out of the kernel, you can keep all the drivers built in. That's just going to take up a memory footprint. So the con about using this kernel, because it's all built in, it's got like pretty much like every driver you'd want. So like the nice part about this kernel is you just like install it and you're pretty much good to go on your drivers, and you can like axe DKMS and KMod and all that, and you're just going to be running on pure built-in, which has quite a decent amount of benefits, especially with security and stuff and performance and like what is it, page faults and stuff like that. Okay, so that's pretty much all the changes I want to make out of here. Oh yeah, one other one. So if you're doing like if you have dual processors, make sure you like all your like if you want like more performance too, you're gonna make sure anything to do with like memory management is kind of like axe. But see, there's a lot of stuff here I use, so I don't like axe it. But like you'd want to keep like KSM off and the page merging and all that. But right now, this is what I'm using. So yeah. I'm gonna go ahead and go back to. I'm gonna save it, and I'm gonna escape. So I saved it, and then what it's gonna go ahead and do is it's gonna be like, see, like it's gonna say your host name matches your set name, so it knows you're not compiling it for another system. It's gonna go ahead and skip those checks for the generic v1 set compiler. That way, what it does is if you change it to other than host name, it's just confirming 100% that you know it can be used on any system. So the nice part about this too is you can use the compiler flags, and it compiles the kernel specifically for your hardware, but you can't just like go move your hard drive and kernel around and stuff, because you're gonna get like kernel locks and stuff when you're trying to boot. It's just not gonna work. But yeah, so that's pretty much it, and then it's gonna go ahead and build the kernel and install it, and that's pretty much it. The current, like I said, the NIT FS on this thing, it's built in, so you're not gonna have to worry about generating a NIT FS and making sure your modules match and all that other stuff. It's just gonna work. Also, it has EFI stub capability, so as long as your motherboard's a little newer, you can just direct boot to the EFI stub, and it just boots. So you're not gonna have to worry about any of that other stuff. And if it fails boot, it drops into a nice init FS that it's like common sense command line driven. You can just like rebound your drive and like exit, go again. So I still gotta add a little more instructions to the custom init FS and stuff. I was gonna put like autocomplete and some nice stuff. So you're like booting into like a mini Linux whenever like if you ever have a failed boot, and you'll be able to like do ZFS recovery options. But yeah, using this kernel, this will get you some more performance for ZFS. It is more stable because everything's built in, so you don't have to worry about like library mismatching, symbol mismatching, stuff that can like crash or pool like when you're compiling and kernels and stuff a lot. That was primarily the main idea of this, just to get that extra performance. I was trying to figure out more about Rust and the Rust libraries, because I'm pretty sure you can backend some of their stuff to Rust, and like just from what I see in Rust, it's like lightning fast with a lot of stuff. So it'd be nice to like get that over to like some of that stuff over to ZFS. That'd be cool to see. So anyway, I hope y'all like this. I hope y'all find it helpful. Hopefully, maybe people will start using it pretty soon, and I can brush up my kitty scripting, use like package fib, make it cross-platform capable and stuff. So anyway, if y'all like the video, like and subscribe. Go ahead and go to the GitHub repository. I'm going to go ahead and open this up for first release on beta, if any of y'all are interested in testing it with me. I've been using it. I've had, like, no problems now. Like, well, I've had a few problems when I first started making it, but this thing's, like, rock solid from what I see. I'm just saying beta because, I got my grammar problems and this and that, and, so, yeah. Anyway, like and subscribe.